Hello and welcome to TypeScript Mastery, Advanced Techniques and Best Practices. I'll be your guide on this exciting journey into the world of TypeScript. In this course, we're going to delve deep into TypeScript, a powerful language built on JavaScript that brings type safety and enhanced scalability to your projects. Whether you're a seasoned JavaScript developer or new to TypeScript, this course is tailored to elevate your coding skills. TypeScript has been rapidly gaining popularity thanks to its ability to catch errors early, make code more readable, and improve collaboration among teams. Throughout the course, we'll cover essential topics like generics, interfaces, advanced types, and practical tips for organizing and maintaining your TypeScript code. Each module is packed with real-world examples, hands-on exercises, and best practices. Remember, the journey of mastering TypeScript is both challenging and rewarding. I encourage you to actively participate, practice the concepts, and engage with the course materials. Thank you for joining TypeScript Mastery, and let's dive in. Welcome once again. In this lesson, we will be setting up the TypeScript environment. If you are already familiar with such a setup, you may simply skip this video and proceed to the next session. Assuming those of you who are still here are curious about how to do the setup, let's start with a basic yet essential point. There are countless ways to configure the environment, and just like our code editors, some have preferences different from ours. Therefore, to avoid giving undue attention to any specific tool, throughout this training, I will be using the playground provided for free on the official TypeScript language website. The first thing to do is to visit the page typescriptlang.org. The link will be available in the comments and resources section below, and click on the playground item in the navigation menu. Once on this page, we can do a number of things, such as selecting the TypeScript version to be used and configuring some additional settings. An interesting point about using this tool is that it generates a unique link that can be shared with others in the future. And this link will also be shared in each lesson with you. The settings I will make are as follows. I will set both the target and module to sNext. Furthermore, in the plugins area, I will select a prettier plugin and another called Format on Save. You can pause the video and copy the settings manually or copy them from the comments and resources section. With that done, our environment is ready and configured. I look forward to seeing you in the next lesson, where we will start to delve into the more interesting parts. See you there. Welcome to the section on generics in TypeScript. Generics are a powerful feature that can make your code more flexible and reusable while keeping it type-safe. Let's dive into what makes generics an essential part of TypeScript programming. Generics allow us to write a component or function that can work over a variety of types rather than a single one. This means you can create a function or a class that can work with any data type while still maintaining type safety. Here, the identity function is a simple example of a generic function. It takes an argument of type t and returns an argument of the same type. The less than t greater than syntax defines the generic type. After calling the function passing the desired types, you can see that no errors are displayed. When running the code, we can see that the values returned are exactly what we expected. And when we hover over the function name inside the console.log method, we can see the parameter type and return type, which are also correct. Generics extend their versatility to interfaces and classes as well. Consider, for instance, crafting a generic interface tailored for an API response object. This approach doesn't encapsulate every property an API might return. However, the spotlight here is on the benefits that generics introduce. In this scenario, the API response interface is adaptable, accommodating various types for the body, such as object or string. This flexibility allows for a more dynamic and type-safe interface, enhancing the interface's utility across different contexts and data types. Generics become increasingly sophisticated when incorporating multiple types and default types. Take, for example, a generic function that is designed with a default type. In this context, the log function is initially set to use the type string by default. However, it offers the flexibility to specify a different type as needed. This adaptability allows for a broader application of the function, ensuring it can handle various data types while maintaining a default for common use cases. For our upcoming class, we'll explore a real-world example of using generics in TypeScript. Remember, applying what we've learned through exercises will greatly reinforce your newly acquired knowledge. Stay tuned for an insightful and practical application of generics. In this class, we're going to dive into the practical application of generics, building upon the knowledge we acquired in our last session. Generics, as we've learned, are incredibly powerful in programming, allowing us to write more flexible and reusable code. Let's start with a real-world example. We'll create a generic stack class. The beauty of this class lies in its versatility. It's designed to work with any data type. This means whether you're dealing with integers, strings, or complex objects, this stack class can handle it all. This adaptability makes it an invaluable tool in a developer's toolkit. For our first example, let's construct a stack specifically for numbers, which we'll call number stack. This is a straightforward application, showing how our stack class can manage a simple data type like integers. It's a great way to see generics in action with basic types, but let's not stop there. The real power of generics becomes evident when we deal with more complex scenarios. Let's explore using our stack class with a person type. Imagine we have a person interface, which includes properties like name, a string, and age, a number. Now, using generics, we can create a stack class specifically for handling person objects. This is where generics shine, providing us the flexibility to work with diverse and complex data structures while maintaining type safety. In our examples, pay attention to how the logs are being printed. They demonstrate the correctness and effectiveness of our generic stack in handling different data types. Also, observe the clarity in code readability and type safety. When you hover over the constants in our code, you'll notice how the types are explicitly defined thanks to generics. This not only makes our code more robust, but also easier to understand and maintain. In real-world programming, such versatility is invaluable. It allows developers to write code that is not only efficient, but also clear and adaptable to various needs. Whether you're building a small application or working on a large-scale project, the principles of generics we're discussing here will undoubtedly enhance your coding practices. In this module, we've covered the generics, their syntax, and how they can be applied to functions, interfaces, and classes. We've also seen some advanced patterns and real-world examples. Generics are a powerful tool in TypeScript for writing flexible and type-safe code. Keep practicing these concepts, and soon you'll be comfortable using generics in your TypeScript projects. In the next module, we'll explore another concept, the interfaces. See you there. Welcome back. In today's session on advanced interfaces in TypeScript, we're looking at how interfaces help shape objects and functions and set rules for classes, leading to better TypeScript code. We start with an interface called car, which has three properties: a brand as a read-only string, model as a string, and an optional year as a number. Here's what this means. The optional year property doesn't need to be included in objects using this interface. The read-only brand can't be changed once the object is created. Trying to change it will cause an error. These features show how TypeScript interfaces offer flexibility and ensure some properties remain unchanged, making the code more reliable and easier to manage. Interfaces in TypeScript can inherit from other interfaces, enabling the creation of more specialized types derived from a broader type. This concept is exemplified by extending interfaces. Let's take a look at an example where we have two distinct interfaces, each serving its unique purpose in different contexts. Yet one interface can be an extension of the other. In our case, the circle interface extends the shape interface. This means that circle inherits all the properties of shape while also adding its own unique properties. Such an arrangement ensures that all required properties from the parent interface, shape, are also mandatory in the extended interface, circle. This becomes evident when we declare a constant myCircle with the type circle. If we omit the property color, which is a requirement inherited from shape, TypeScript flags an error indicating that the color property is missing. This demonstrates how extending interfaces helps in maintaining consistency and enforcing type safety across related types. TypeScript's ability to implement interfaces with classes is a powerful feature, offering a structured and consistent approach to coding. This capability is vital for large-scale application development, where maintaining standardization and predictability in code structure is essential. In our first example, the clock class implementing the clock interface demonstrates this concept. The interface acts as a contract, specifying that any class implementing it must have a current time property and a set time method. This ensures uniformity and predictability across different implementations of the same interface. If a developer mistakenly omits either the property or the method, TypeScript's type checking intervenes, providing immediate feedback in the form of errors. This mechanism significantly reduces the risk of runtime errors and bugs, particularly in large and complex code bases where such issues can be challenging to track down. The second example delves into defining function types within interfaces, a less common but equally valuable practice. The search_func interface specifies a function type with two string parameters and a Boolean return type. This design pattern is especially useful when multiple functions across the application must adhere to a specific signature. Implementing such interfaces ensures that any function conforming to the search_func interface will have a consistent and predictable behavior, which is crucial for team collaborations and when integrating different parts of a project. This consistency aids in debugging and testing, as developers can rely on the defined structure. Alright, in our discussion so far we've covered three big topics about TypeScript interfaces. First, we talked about optional and read-only properties in interfaces, which helps us control what can or cannot be changed and what's not required. Then we explored extending interfaces, which is like adding more features to our existing rules. Lastly, we dived into how classes and functions work with interfaces, making sure they follow the rules we set. Remember, it's super important to practice these concepts to really understand them. Try out the examples yourself. Also, don't forget to check the comments and resources section below for all the links and examples we used. This will help you see how everything works in real situations. That wraps up what we've learned so far. Next time, we'll put all these ideas into a real-world example. This will show you how valuable interfaces are in real projects. See you in the next class for some hands-on learning. Welcome back. In this session, we're going to construct a straightforward user management system, applying our acquired knowledge from this module. Imagine we are building a user management system for a web application. We need to handle different types of users: administrators, regular users, and guest users. Each user type shares some common properties, but also has unique attributes. The code is divided into three sections: 1. Base and extended interfaces, 2. implementing interfaces and classes. 3. Using interfaces and classes. In the first part, we will use a base user interface to define the common properties and then create 3 interfaces to define the unique properties and methods for each user type. Also, as we can see in the code, the base user interface has one read-only property and one optional property. The read-only property is the type that only accepts the values admin, user, or guest. For each of the user types that inherit from the base user interface, we will define the type and the required properties. In the second part, we will create 3 classes that implement the interfaces we created in the first part. Each class will have a constructor that will receive the required properties, and the read-only type property will be defined in the top of the class. We are not going to implement the methods, but since they are required, we will add them to the class. As we can see, this is the case for the method manageUsers in the admin class and the method postComment in the regular class. In the third part, we will instantiate the classes and call the methods. At this point, the methods will not do anything, but we will see that we can call them without any errors. Lastly, we introduce an interface called printUserBasicInfo and define that will require a param called user. For this interface, we will create a function that will receive a user object and return a greeting message based on the user type. This message will contain the username, email, and the type. With that, we wrap up the Advanced Interfaces module, having explored the profound capabilities of interfaces in fostering cleaner, more orderly code. This approach not only simplifies coding, but also mitigates errors and maintenance challenges in the future. I hope you found this module insightful. Remember, practicing what you've learned is key to solidifying your understanding. Looking forward to seeing you in the next module. Hello, and welcome back. In this module, we're diving into the intricate world of advanced types, union types, and type guards in TypeScript. These features are cornerstones for writing flexible, robust, and type-safe code. They are especially crucial in scenarios where precision in type annotations is necessary. Today, we will explore these concepts through a practical, real-world example. This will not only demonstrate their application, but also highlight their significance in solving complex coding challenges, such as managing diverse user actions in web applications. Let's get started. In any web application, users can perform a variety of actions, sending messages, uploading files, updating their profiles, and more. Each action demands specific data types and handling. How do we efficiently manage these differing requirements? This is where union types and type guards come into play. Let's follow the step-by-step breakdown. 1. Defining action types. First, we define a type for each user action. This includes send message, upload file, and update profile. Each type specifies the data needed for that action. 2. Creating a union type. Next, we introduce a union type named user action. This union type is a collection of all our action types. It's a versatile way to group different types under a single umbrella, enabling us to handle multiple types in a unified manner. 3. Implementing type guards. Then, we implement type guards. These are functions that allow us to determine the specific type of action we're dealing with at runtime. Type guards are crucial for ensuring that we process each action correctly according to its unique data requirements. 4. Handling actions. Finally, we write a function, handle user action, that takes a user action type as an input. Using the type guards, this function can discern which action it's dealing with and process it appropriately. We'll see how our code handles different user actions, sending a message, uploading a file, and updating a profile. This practical example illustrates the power of union types and type guards. They enable us to write a single, coherent function that can manage various action types securely and efficiently. An important point to note is that removing type guards leads to TypeScript errors. Without them, TypeScript can't differentiate between the action types. The type guards are essential for our function to understand and correctly process each action type, especially when these functions are referenced across different parts of our code base. Today we've delved deep into advanced types, union types, and type guards in TypeScript. These concepts are not just theoretical, but have real-world applications that enhance the flexibility and safety of your code, especially in complex scenarios involving multiple data types. I encourage you to implement these in your TypeScript projects to experience their full potential. Stay tuned for our next module, where we'll explore another exciting aspect of TypeScript. See you in the next session. Welcome to our module on code organization and modularization in TypeScript. In this session, we'll explore how to structure your TypeScript projects effectively, making your code more maintainable, scalable, and easier to collaborate on. Let's dive in. Good code organization is crucial for any project, especially as it grows in size and complexity. It helps in managing dependencies, simplifying debugging, and enhancing readability, which is vital for team collaboration. Let's start with the basics of a TypeScript project structure. A well-organized project typically includes directories for your source files, tests, configurations, and assets. As we can see in the image, this is the most straightforward way to organize your project and is suitable for small projects. Also, when you are not sure about how big your project will be, this is a good starting point. However, as your project grows, you will need to organize your code into modules. In the comments and resource section below, you will find a link to the original documentation on modules in TypeScript. Modularization involves breaking down your code into separate modules or files, each responsible for a specific functionality. TypeScript's module system helps in organizing and managing code effectively. We may also want to organize our code by features, which is a common practice in software development. This approach, often called feature-based organization, groups all related files, like models, services, and tests, for a specific feature together. As we can see in the image, this approach is suitable for medium to large projects, since it helps in managing dependencies and simplifying debugging. It is also worth mentioning the directory called shared. This directory contains shared or common functionalities, such as utility functions, and group them in a shared or core module. This avoids duplicating code across different parts of your application. As your project grows, maintaining scalability and manageability is key. Regularly refactor your code to ensure modules remain focused and don't grow too large. Effective code organization and modularization in TypeScript are essential for building scalable and maintainable applications. By structuring your project into clear, focused modules and organizing code by features, you set a strong foundation for your application's growth and success. Remember, there's no one-size-fits-all approach, so feel free to adapt these practices to fit your project's needs. That's it for this class. See you in the next one. Welcome to our class on common design patterns. In this session, we'll explore some design patterns that are highly effective in TypeScript programming. These patterns provide structured approaches to solving common software design problems. Let's get started. Design patterns are standardized solutions to common problems in software design. They're like templates devised to tackle issues that repeatedly occur during development. Understanding these patterns is crucial for writing efficient and maintainable TypeScript code. First, let's talk about the singleton pattern. It ensures a class has only one instance and provides a global point of access to it. This is useful for managing shared resources. In our example, we can see a class that connects to a database. We want to ensure that only one instance of this class is created. We can do this by making the constructor private and creating a static method that returns an instance of the class. This method will create an instance if one doesn't exist, or return the existing instance if it does. Next, let's look at the factory pattern. It provides an interface for creating objects without specifying their concrete classes. This is useful for creating objects that share common properties. In this example, we have a factory class that creates products. The factory class has a method that takes a type parameter and returns a product based on the type. This allows us to create products without knowing their concrete classes. It's also easy to add new products by simply adding a new class and updating the factory method. This is a great way to decouple the creation of objects from their usage. It is worth mentioning that both TypeScript will warn us, and an error will occur if we try to create a class with a non-existent type. Finally, the decorator pattern. This pattern allows behavior to be added to individual objects dynamically without affecting the behavior of other objects from the same class. In this example, we have a component interface that defines an operation method. We also have a concrete component class that implements this interface. Finally, we have a decorator class that takes a component as a constructor parameter and adds functionality to it. This allows us to add new functionality to an object without modifying its class. It also allows us to add multiple decorators to an object. Today, we've covered some of the most common design patterns in TypeScript, including singleton, factory method, and decorator. These patterns are essential tools in your TypeScript toolkit, helping you write more organized, efficient, and maintainable code. For those who are keen on exploring additional patterns, the Comments and Resources section contains valuable links to various design pattern documentations, as well as an intriguing project that showcases a range of well-known patterns in the industry. That's it for today. See you in our next class. Welcome to our class on creating scalable and maintainable TypeScript code. In this session, we'll delve into key practices that ensure your TypeScript projects can grow without becoming unwieldy or difficult to manage. Let's enhance the longevity and quality of your code. Embracing TypeScript's type system. My first tip is to fully embrace TypeScript's type system. Make the most out of TypeScript's capabilities for static typing to catch errors early and make your code more understandable. Consistent coding conventions. Adopt consistent coding conventions. This includes consistent naming patterns, file organization, and code structuring, which are crucial for maintainability. Leverage interfaces and types. Use interfaces and types effectively. They are powerful tools for defining the shapes of objects and function signatures, making your code more predictable and easier to refactor. Modularize your code. Modularize your code. Break your codebase into smaller, reusable modules. This not only makes your code more manageable, but also easier to test and debug. Effective use of generics. Generics are a boon for creating flexible and reusable components. Use generics to write functions and classes that can work with multiple types while keeping the advantages of strong typing. Prioritize code readability. Readable code is maintainable code. Prioritize clarity over cleverness. Opt for clear and straightforward code that your future self and your teammates can easily understand and modify. Regular refactoring. Don't shy away from regular refactoring. As your project grows, continuously refactor your code to improve its structure, eliminate redundancy, and enhance performance. Adopt linters and formatters. Use linters and formatters like ESLint and Prettier. They enforce code quality and consistency, helping you avoid common mistakes and maintain a uniform code style. Today, we've covered essential tips for writing scalable and maintainable TypeScript code. Remember, the key is to write code that not only works but is also clean, understandable, and adaptable for future changes. Keep these tips in mind as you build and scale your TypeScript projects. As always, take a look at the comments and resources for more information and useful links. Thanks for watching, and see you in our next module. Welcome to our session on review and key takeaways. Over the course, we've covered a wide range of advanced TypeScript topics. Today, we'll recap the most crucial points to ensure you carry forward the essential knowledge and skills. Let's begin with a recap. We started by setting up your TypeScript environment, ensuring you have the right foundation. Then, we dived into generics, where you learned how to write flexible and type-safe code. We also explored the world of interfaces, understanding how to define structured contracts for your objects and functions. We delved into advanced types, mastering union types and type guards, which are pivotal in handling complex data structures. Our practical TypeScript sessions covered code organization and modularization, common design patterns, and tips for scalable and maintainable code, equipping you with best practices for real-world development. Remember, TypeScript is a powerful ally in writing clean, maintainable, and error-free code. Embrace its full potential, practice consistently, and don't hesitate to revisit these modules for a refresher. As we conclude this review, I encourage you to keep learning and experimenting. TypeScript is constantly evolving, and staying updated with the latest features and best practices will be key to your growth as a developer. That's all for this class. See you in the next one. Welcome to our penultimate session, final thoughts and moving forward. Today, we reflect on our TypeScript journey and discuss how to continue growing as a TypeScript developer. We've journeyed through the depths of TypeScript, uncovering its capabilities and how it can revolutionize your development process. You've gained the tools and knowledge to tackle complex coding challenges with confidence. The world of development is ever changing. Embrace these changes as opportunities for growth. Continue to challenge yourself with new projects, contribute to open source, or even mentor others in TypeScript. Stay updated with the latest TypeScript updates and community best practices. Join forums, follow blogs, and participate in discussions. The TypeScript community is vibrant and full of resources to support your continuous learning. Remember, the end of this course is just the beginning of your journey. Keep coding, keep exploring, and never stop learning. The path of a developer is a lifelong journey of discovery and growth. That's all for this session. See you in our next and final class of this course. Here we are at the end of our TypeScript Mastery course. It's time to say farewell and good luck. But before we part ways, let's take a moment to reflect and look ahead. We've covered a lot of ground in this course, from the foundational aspects of TypeScript to advanced concepts. I hope these lessons have not only expanded your technical skills, but also sparked a deeper interest in software development. Your journey with TypeScript doesn't end here. Ahead lies a path filled with exciting projects, challenges, and continuous learning. Apply what you've learned, experiment with new ideas, and don't be afraid to push the boundaries of your capabilities. As you move forward, remember that perseverance, curiosity, and a willingness to learn are your greatest assets. The road of a developer is sometimes challenging, but it's also incredibly rewarding. I want to thank you for your dedication and hard work throughout this course. It's been a pleasure teaching and learning with you. Keep coding, keep exploring, and remember, the TypeScript community is always here to support you. Farewell, and good luck on your coding journey.